Nomenclature of alkyl halides. What are alkyl halides? When you replace one of the hydrogens in an alkane with an halogen, then it's going to lead to alkyl halides. Here are some examples for it. This one right here is a primary alkyl halide because the halogen is connected to a primary carbon. So this is a primary carbon, and therefore this is a primary alkyl halide. Similarly, this is a secondary carbon, and this is a secondary alkyl halide, and this one is a tertiary alkyl halide because the halogen is connected to a tertiary carbon which is connected to 3 other carbons. Common names versus systematic nomenclature. The common names for alkyl halides is simply an alkyl halide itself. Say for example, this is derived from methane, and after replacing one of the hydrogens with a chlorine, it should be called as methyl chloride. And likewise, this is called as ethyl fluoride. And this one is called as isopropyl iodide. As you can see that this group right here is an isopropyl unit. And this one is a secondary butyl bromide. There are 4 carbons and the bromine is attached to a secondary carbon. Therefore, this is a secondary butyl bromide. Now for the IUPAC name, we are going to adopt the rules that we have used for the nomenclature of alkane. So here, this has been derived from methane. So parent name should be ending with methane. And on methane is present a chlorine, so it should be simply called as chloromethane. And we don't have to be worried about giving the numbers for it since it has got only 1 carbon, right? And for the next one, this is called as fluoroethane. Here again, we don't have to be worried about giving numbers because by default, this fluorine is attached to carbon number 1. And for this one, we have to give the numbering, right? So here is the numbering, and the iodide group is present on carbon 2. So it's called as 2-iodopropane. And the next one, here again you're going to give the numbering. We are going to make sure that the bromine gets the lowest possible number because this is acting as a substituent. So 1, 2, 3, 4. So it's going to be 2-bromobutane. Let us do some more examples. Here is an alkyl halide where there are 2 substituents. We have an alkyl substituent, we have a methyl group, and we also have a bromine. And this is our longest chain. And which direction are we going to go in? So as you go from left to right, that puts the methyl group in the 3rd position. But as you go from right to left, that puts the bromine in the 2nd position. So we wanted to go from right to left to make sure that the substituents get the lowest possible number. Right? So it's going to be 2-bromo 5-methyl heptane. So the structure is, so the name of this compound is 2-bromo 5-methyl heptane. Let's go on to the next one. So we're going to again find the longest carbon-carbon chain. So our longest carbon-carbon chain has a total of 7 carbons in it. So it should be named as heptane. And what are the substituents? So we have a chlorine and we also have 2 methyl groups. Now which direction are we going to go in? So we're going to go from right to left. So if you go from right to left, that puts the first substituent, which is chloro, in position 1. But if you go from left to right, that puts the 2 methyl groups in the 2nd position. But you need to make sure that at least one of the substituents needs to get the lowest possible number. And if you can give the lowest possible number to the substituent, then you have to adopt that as the right numbering. So the name for this molecule is 1-chloro-6,6-dimethylheptane. 1-chloro 6,6-dimethylheptane. Let's go on to the next one. This is a cyclopentane. So that should be the parent name for this, because there is no side chain which has more number of carbons in the actual cyclopentane ring. Cyclopentane, and you have an iodo group here and you have an ethyl group here. So between these two, which one of this is going to be having the lowest possible number? So this is more like a tie, right? Both are substituents. You do not have any functional group here. So in which case, whichever is going to come first, the ethyl group is going to come first in the alphabet. So that should be assigned as number 1. And you have to assign the next carbon as number 2. So you're going to go in this direction. So the name for this is going to be 1-ethyl 2-iodo cyclopentane. Let's go on to the next one. This is a cyclohexane ring. Now you have 3 substituents in here. So you have a methyl group and you have a bromine and you also have a chlorine. So between these 3 substituents, which one is going to be assigned as number 1? So here the lowest number is going to take priority. We need to make sure that all of these substituents get the lowest possible number, for which we are going to choose either the methyl group or the chlorine to be at 1. Now which one are we going to choose? Are we going to choose the methyl group or the chlorine to be at 1? It would be wise to choose the methyl group to be at position 1. So in that way, the second substituent and the third substituent is reached with shortest distance. So the name for this molecule is going to be 4-bromo 2-chloro 1-methyl cyclohexane. You want to choose any one of this is going to be a as position 1.